Hello everyone, thank you for joining me today. I'll be presenting how vendor-agnostic deep learning tools, particularly Claric City AI, are changing the game in city image making scans safer by drastically reducing radiation without sacrificing image quality. So, why dose reduction matters? CT scans are indispensable in diagnostics, but they expose patients to ionizing radiation. This exposure becomes especially concerning for children, chronically ill patients, or anyone needing multiple scans. Traditionally, lowering the radiation meant worse images, but not anymore. With AI-based diagnosis, we can now decouple those from image quality. Some challenges of commercializing denoising techniques, limitation of current solutions. Many CT vendors offers built-in denoising features, but here's the catch. They are only available in their latest premium models. That makes widespread dose reduction difficult, especially in lower income regions or smaller hospitals with older hardware. This creates disparities in patient care, particularly in regions with fewer resources. Enter Claricity AI. This is where Claricity AI comes in. It's a deep learning denoising software that is vendor agnostic, works across machines from GE, Siemens, Philips, etc. Software based doesn't require new hardware, clinically validated, already used in real hospital settings. Study design, clinical evaluation was done using 180 patients, 100 chest scans on GE machines, and 80 abdominal scans on Siemens machines. Each patient received two scans. A raw dose scan using the vendor's built-in reconstruction algorithm, and an ultra low dose scan at one third to one tenth the radiation reconstructed with Claric City AI. Oh, radiologist image evaluation. Three thoracic and three abdominal radiologists evaluated noise, resolution, lesson clarity, and overall quality. Surprisingly, the AI enhanced ultra low dose images scored equal to or better than the routine dose images. So it means we can have like widespread accessibility and flexibility. And of course, we have to handle like some limitation of commercializing solutions. This limitation hinders their availability and adoption in resource-limited settings, reducing the overall potential for radiation dose reduction and image quality enhancement in broader clinical applications. We have like some quantity results. Looking at the chest CTs, effective dose dropped by up to 90%, image sharpness actually improved, and noise levels are comparable for abdominal CTs. Dose reduced by approximately 67%, image quality remained clinically acceptable. Yeah, like I mentioned, Claric City AI effectively enhance image quality in low dose CT scans. Vendor agnostic solutions. The solution is designed to function across various CT systems, ensuring widespread access and usability in clinical settings, especially with some older hardware hospitals or smaller hospitals, and radiation dose reduction. Um, Claric AI, Claric City AI allows for significant reduction in patient radiation doses while maintaining high quality imaging, enhancing patient safety. Study design and methodology, an overview of studies approach to assess the effectiveness of Claric CTAI in reducing patient radiation dose. So some effective dose comparison to give numbers, chest scans dropped from zero point 0.9 to zero point 0.1 millisievert in men and zero point 0.8 to zero point 0.1 millisievert in women. Abdominal scans dropped from 4.5 to 1.5 millisievert in men and 5 to 1.6 millisievert in women. This is major advancement in patient safety. Dataset collection, a paired CT dataset was collected from a university hospital, including routine dose and ultra low dose images of chest and abdomen from the same patients. And we already know that the numbers dropped significantly. The study included data from 100 patients divided into women and men using a Revolution CT scanner and 80 patients using a Somaton 4 CT scanners. CT scanners details. Routine dose images were obtained using HRV method on the Revolution CT scanner, while ultra-low dose images used filtered back projection and Claric CTAI for denoising. Expert radiologists evaluated the clinical image quality and conducted quantitative analysis to measure image noise and sharpness, including robust assessment. So as we know, clinical image quality was assessed through subjective evaluation by expert radiologists who rated images on 5-point Likert scale based on criteria such as noise, resolution, and overall quality. This method provides a comprehensive understanding of the perceived image quality in different dose settings. Quantitative image analysis. Quantitative analysis was performed to objectively measure image noise and sharpness. Metrics such as standard deviation of house field units were used to quantify noise, while edge rise distance was employed to evaluate sharpness, providing a detailed assessment of image quality. Yet the chest CT set demonstrated that ultra-low dose images achieved a clinical image quality score of 3.89, significantly higher than the routine dose images, which scored 3.02. Noise levels in ultra-low dose images were comparable at 52.19 HU compared to 47.14 HU in routine dose images, while sharpness improved, indicated by a better edge, rise distance of 1.3 millimeter versus 1.46 millimeters. Routine doses. This suggests that deep learning based denoising effectively enhance image quality even at reduced radiation levels. Like all studies, there are limits. This was done in single center setup. More multi site trials would strengthen generalizability. Long term clinical validation is ongoing. Still, results are extremely promising. In the chest CT set, effective dose was significantly reduced from 0.0 9 to 0.1 millisievert as I mentioned, and also the same um, values was in abdomen CT dose reduction. So the conclusion, to wrap up, deep learning CT denoising is no longer just a research toy. It's clinically become reality. We can reduce dose by up to 90% while maintain improving image quality, and best of all, it's accessible to everyone, not just the high-end hospitals. So thank you for your attention, and I'm happy to answer any questions.